Привет всем, я надеюсь, вам понравился партнерский блог. Теперь мы приступим к тому, что нас ждет в нашем докладе и вообще, что нас ждет параллельно. Значит, сначала в первом треке у нас будет Андрей Лушников рассказывать про Playwright, новый майкрософтский фреймворк для автомации в веб-браузере. Вот. В третьем треке у нас будет рассказ про рендеринг HTML и как это сделать быстро. В четвертом же у нас продолжится воркшоп, в котором будет рассказываться про Postgres для JS-разработчиков. А в нашем треке нас ждет замечательное интервью и Q&A-сессия с Дэвидом Ноленом. Готовьте ваши вопросы, потому что вопросов должно быть много. Надо 75 минут постараться. Я надеюсь, что у вас они есть и что они появятся в будущем. Поэтому я представляю двух экспертов, которые будут проводить сейчас это интервью. Это у нас Андрей Зайцев и Николай Рыжиков. Все правильно? Всех? Никого не перепутал?
Да, привет, ребята.
Вот, давайте теперь...
Hey, guys.
Давайте теперь поприветствуем Дэвида. David, hello. Are you hear me? Do you hear me?
I can hear you loud and clear.
Yeah, great, great. Okay, so I will leave you alone and please have fun. Good luck and have fun.
Nice,
Thanks.
thank you. So, thank you,
All right.
David, for
So
joining
maybe I'll
us.
just, yeah.
Yeah, welcome to the show. So yes, we know you as a one of maintained developer of ClojureScript, but I think it's better if you introduce yourself because I think you're bigger than just a developer of ClojureScript. So please introduce yourself.
Hi, my name is David Nolen. I'm a software engineer. Currently, I work for a company called Vouch.io, and we're in the sort of cryptography, digital key identity space. It's a pretty interesting small startup. The cool thing is that everything that we do is written in Clojure. So every component of our stack, all the crypto bits and the backend services, we're building 2 React Native applications. One's like a sample thing, and one is an Android iOS key application, identity application. And yeah, so we just use ClojureScript everywhere. I mean, I think the only place where we don't use it is like in our current line of work. We do have to write some C code, which is unfortunate. We'd be writing a Lisp. But for those of you that might not know, is that Clojure is a functional programming language. Came out in 2007. It targets the Java virtual machine. You have a question? Go ahead, Nikolai.
Yeah. Let's move slowly. So I think the question: how did you to the Clojure community? How you joined it? So can you tell this story? And probably why you pick the Clojure, not
Sure.
Erlang or something else.
Yeah.
So let's start slowly. We have a lot of time, so let's. Yeah.
I agree. So what happened was that I was doing software, like I've been doing JavaScript since 2005. IE6 at that point was still need to be supported. So I remember the days before Firebug, long before modern JavaScript was a thing, script tags, all this stuff, browsers crashing because you wrote the wrong ActiveX thing, in your CSS file. And you'd have to go through your CVS history to figure out what happened. So I've been doing JavaScript a long time. I've been through the jQuery,
iframes,
iframes, lots of iframes. I remember when Ajax was like a new thing. So I've seen JavaScript change a lot. So it's a long story, but to cut it short, I was actually a Ruby developer and JavaScript developer at the New York Times for 4 years. Actually, my coworker was Jeremy Ashkenas, which some people might know because he worked on script. So it was funny. So we were doing a bit of JavaScript and CoffeeScript and Ruby. And at the time, I had already gotten to Lisp. Like Lisp, I had like read some Lisp books. And I was like, Lisp is so weird. It's so old, but it's still cool. It's like one of the oldest programming languages, right? There's still in use and is recognizably similar to the original thing. The only thing that's really like that today anymore, I think, is like Fortran, right? Like Fortran looks pretty much the same as it did back in the day. Lisp does in the, there's different language features, but most of John McCarthy's ideas about functional programs, recursion, the list data structure, all this stuff, REPL, the REPL was, the original REPL was a typewriter, was a network connected typewriter, like before, like screens were pervasive. So anyways, I was into that. And I was always like, CoffeeScript showed that people weren't completely against compiling to JavaScript, right? You have to remember, back then people were like, I will compile JavaScript. Like, I'm never going to compile to JavaScript, which is like, you look now and like everybody's compiling to JavaScript. It's just JavaScript to JavaScript, but everybody's compiling JavaScript, right? But back then people were like, I'm never going to compile script. And CoffeeScript paved the way and showed that there was an audience for people who didn't mind compiling the JavaScript. And what happened was in 2011, I had been at the New York Times for 1 year. Rich Hickey, who created Clojure, created a version of Clojure that could compile to JavaScript. That was called ClojureScript. And I've been open source for for a long time, like a lot of developers are. And I saw, having done JavaScript for such a long time, I was like, oh, finally, like my passion plus my line of work, JavaScript. So I started contributing to ClojureScript. So that's really how I got involved. It was very much like a open source fun thing for quite some time. And then in 2014, I actually went to work with Rich Hickey's company, Cognitech, and I got to do ClojureScript full time there. I've since left, but and that, it was great. I had a great time working at the sort of Clojure company, and now it's pretty cool. Like, ClojureScript has a small but very loyal and active community, and I get to use it for work. So like it all worked out in the end. So cool.
Yep. And
So
can you tell like
okay. So how did
Andrea?
the ClojureScript
Yes.
looked back then when you just approached it, when you started trying stuff out? Like how different it was from what it is now, and what you like?
So that's a great question. It's very different now. I mean, one of the biggest differences, to be honest, was React. So prior to the appearance of React, Clojure and ClojureScript are functional. So they are oriented around immutable data structures. And most of the JavaScript frameworks that you would do serious work with, whether it's back then, it was Query, you had Backbone, I think Ember at that point was happening, Marionette. Yes. There were so many of these, right? There's so many of these MVC frameworks. Problem was that using an object, or there's nothing actually wrong with the object-oriented part, but using a traditional MVC framework meant that you were dealing with something mutable and stateful. So using ClojureScript to write UIs, it was cool, but you felt like, as I'm just writing JavaScript with ClojureScript, which was kind of missing the point. And in 2014, React had come out. 2014 was it? 2014. It had come out that summer to, everybody was like, this is the dumbest thing ever, right? And now we've come full circle. Now people are hating on React because it's just so popular. But back then, people hated it because it had XML literals. And I was like, I don't really care that much because I didn't really understand it. But my friend was also doing Brandon Bloom. He was dabbling in ClojureScript, and of course had followed React and was like, actually, there's this really cool feature in that I bet you could use this from a functional language and it would be a better integration than it would be with a traditional MVC. And then Jordan Walk, the original creator of React on Twitter, was like, I just replaced and they were building a comments feature in Facebook. I just replaced the backing store of our comments feature with a persistent data structure, and I got a 10x speed boost. And I was like, whoa, they're using persistent data structures at Facebook. And then I was like, well, do you think it would be, I messaged him directly. I was like, do you think it'd be easy to integrate that from a functional language? He was like, I think that'd be easy. And then I met with Peter Hunt, who was an evangelist for React at the time. And we had a coffee across the street from the New York Times. It was Brandon Bloom and Peter Hunt and I was like, sat down and I picked his brain for about an hour and a half. And then I went home, and it took me about 2 weeks. And I was able to show that actually React was much more idiomatic integration. That even though React had an object-oriented facade, the semantics of it were better for functional programming languages. And it was interesting because I gave a talk about it, I think, after I did Ohm. That was like my first React ClojureScript integration. I gave a presentation about it 3 months later at a Clojure conference. And at the time, I asked the audience, there was about 400, 500 developers, how many people in this audience have heard of React? This was early 2015. Nobody at your conference even knew what React was. 6 months after that, everybody knew what it was. And ClojureScript, ClojureScript still needs to grow its community base, but overnight, the Clojure community almost instantly embraced script, right? It went from ClojureScript's that weird thing, you have to be a little bit, bananas to use it, to being like, wow, I get to use all the things I love about Clojure, and I can build functional UIs that are easier to understand with respect to state. I mean, of course, in the end,
Yeah,
UI
I
programming
remember,
is challenging.
I remember your post when you wrote the post about the React plus ClojureScript, which is beat the manually optimized backbone.
Yeah.
And I think you helped React with the popularity, because I think even not ClojureScript developers saw this post and they start thinking, what is React? At least it's about a story about me. So when I read this post, so the first question was, what is React? So your post was even before React, and I think it helped a little bit React to get more popularity.
It's funny because I used to be a more active blogger, and that post was like the most popular post I ever wrote by like 10x. So like it take all the page hits that all my other posts had ever gotten, and that was 10 times more than all the others combined. So yeah, you're right in that the impact was far beyond ClojureScript. Sure, that convinced the Clojure community to embrace ClojureScript and React, but yeah, for sure, that triggered, I think, the beginning of a lot of outside of, in the JavaScript community. It got people to look at React a second time.
I think it is worth it to reiterate how persistent data structures are actually very useful when you're doing stuff like React. And that performance boost you just mentioned, was it because of how easy it is to compare two immutable data structures if they are equal, and then to decide to optimize something? Like just...
Right. So that's a good point. When I talked to Jordan Walk, there's this feature called should perform update. I can't even remember it anymore. It's hit like all the libraries I use hide that thing. But yeah, you're exactly right. Persistent data structures, the way that they work is that nothing has changed, because the way that they work is that if the root reference is the same as it was before, then it's not possible that anything was mutated underneath the root of the tree. So what you could do is you could just do a pointer comparison. You could be, is this the same root as it was before? The data, just the data of your UI state. If it's the same root, we don't have to do deep equality. If the root hasn't changed, you don't have to check anything. And the cool thing is that as you render the tree, if the root did change, what's going to happen is that as you render the UI graph, you're going to be checking at each point, well, is it equal at this subtree? Is it equal at this subtree? And it means that there was like huge areas where React would never do anything if you use persistent data structures. I mean, again, to be fair, after a couple of years, I mean, it turns out that there are other things you need to do. But the point about what I was trying to say is that it was great how much performance you got with very little additional effort. Really new, right? Because previous to that, when you were talking about something like Backbone, really to optimize it, you have to keep these sorts of optimizations in your mind. You have to be like, oh, I don't want to trigger a bunch of DOM updates. I want to combine the DOM-8s. I want to like the balance, whatever. There's all these tricks that become like things you have to remember. And I found it very interesting that with this sort of immutable standpoint, you could get pretty good performance out of the box. And then, of course, there's just like as there is with any system, there's a host of other tricks to get more performance. I just thought it was really fascinating that with some good choices, that the performance could be quite good without caring about it. I mean, that I think is the most important thing, right? As a programmer, you're like, how can I get decent perf and not really sit around and have to think about that problem, especially when you're doing a new effort or you're starting something new. It's nice that when optimization is a detail, it's an extra bit of work you do later rather than something that's sort of pervading your work all the
So David, can we make some technical introduction? What is Clojure? What is ClojureScript? Because guys mostly from JavaScript land. And can you try to convince them and give the reason why they should look into this area, and what's new they can get from the Clojure if they try to learn this language, and why it works?
Well, so I mean, if you like, there's a few things to talk about here, because there's one pretty big trend in the JavaScript community, which is TypeScript. So TypeScript has gained a lot of popularity. So I think we should come to that. But really, ClojureScript is, if you're a JavaScript developer, ClojureScript, I think, is not as big of a leap as you would think. I liked JavaScript back in the day because JavaScript's dynamic, it's flexible, it's fun, and I think to a large degree it's quite capable. I mean, people like to say, there's arguments on both sides of whether you can build large software or not with dynamically typed languages, but I think the truth is that there's so much JavaScript out there in many application points, whether that's mobile applications, massive websites. I think it's still debatable whether it's important that you need types to write software. I'm not saying that they're not useful. They're certainly very useful. But I think JavaScript has shown that you can be very effective with dynamic programming languages. So if you believe that, or you don't think that it's a deciding factor in whether software succeeds or fails, which that I think is the most important question. People want to say that there's some specific thing that causes a software project to fail, and in truth, it's almost never the technology. It's people, organizations, and processes. So if you buy into that, then I think, why ClojureScript over like JavaScript? And I would say ClojureScript is like JavaScript in that it's dynamic. It has a small set of really great data structures. Another thing about JavaScript that's great is that it's simple. You have maps, you have arrays, objects and arrays, and there's some power in the simplicity of that. And Clojure is also very similar. It's data-oriented. A good example of why this is cool is that you look at the JavaScript ecosystem and you say, why did it explode? Why is there so much tooling? Why are there so many compilers? And I would argue that one of the biggest reasons is that JavaScript defines its AST as JavaScript data, right? You don't have to have typed ASTs, right? You have a standard AST format. Any friggin' tool can consume it, and I don't have to share like a bunch of AST nodes with my specific types, right? That there's power in the fact that the AST is generic. It's represented as JSON. You can read the specification, and I can write a tool, and I don't need to subsume too many other libraries to write a custom pass or a tool and add a Babel thing. I mean, that's something that people really need to think about. The reason the ecosystem has exploded there is because it's really easy to write tools around the shared AST representation script. So that's like huge, right? Data, right? A truly agnostic data format that you can move around. It's great. I mean, that's a huge lesson from JavaScript. And you see that JSON is still the advantages over highly specified data exchange formats. There's the flexibility of JSON is here to stay. So ClojureScript says if it's good for every part of your system, if you're already using JSON to deal with tooling, to deal with your data exchange, then Clojure says take that to another level. We can write entire programs around that format, and they can be very effective. And just to give you a sense, this is not just me, like, we could say this and it would be like empty market speak if we didn't, eat the dog food. ClojureScript actually, ClojureScript itself, the AST, Clojure actually, to this day, Clojure the AST is modeled after Java types, and it will never escape the JVM. So all these Java types, it's like that compiler is not reusable. And Rich Hickey, when he did ClojureScript, was like, that wasn't great. That's really not awesome. And so he wanted a pure data representation for the Crypt AST. So it's represented as Eden. So ClojureScript is now some 50,000 lines of Clojure, and the entire AST, just like JavaScript represented as JSON, ClojureScript represented as Eden. So where, Eden, when you think Eden, all you have to think is that's Clojure's version of JSON. It's a generic data representation that any Clojure program can consume. It's maps, in fact, instead of being objects and arrays. And so we've maintained a piece of software now for almost a decade, and it's not hard to maintain, right? It's not hard to maintain. We represent the AST as data, and there's a lot of power in that. And again, when we build our systems, or the programs we're writing, for work, again, we use the same philosophy, and I feel like still today that it has a lot of benefits. Hopefully that answers some of your questions.
Yes. So how you call it? Probably maybe data-driven development or metadata-driven development. I don't know. We see that there is a lot of use of data in Clojure. So people create like data DSLs and then write some interpreters in Clojure or ClojureScript, and this definitely reduces the size of the program because the part of the logic is pushed to the data land. And I think that's this piece of this discussion between types and Clojure, because we can reduce the size of the program using the data-driven development. I mean, data DSL.
Yeah, I mean, Clojure. No, I do. I mean, Clojure programs tend to be small, and they tend to stay small. I mean, you could probably I don't know how big TypeScript is or any of these other things are, but I'm sure they're pretty big. The rate of growth is larger than ClojureScript. ClojureScript started as 500 lines of code, and when I say 50,000 lines of code, that's not really it includes all tests. That includes all the testing that we do for all the different environments, browsers, Node.js. It involves testing about build tool testing. We have a bunch of build tool functionality. Really, in truth, the total core of the system is only about 20,000 lines of Clojure, and we're only adding maybe a couple hundred lines of important stuff every 6 months. So that's another thing that's really important.
Can you explain it? It's still mystically why the Clojure programs are so small, because it's definitely not syntax. It's something different in approach, how we approach the program. So I saw that it can be 10 times or even a couple of orders magnitude less than the similar code in Java, for example, or even TypeScript or something like this. But you could not explain this just by syntax. Yes, why is Clojure program are so small?
Well, so I mean, I will say, I mean, something that that's a great question. The thing that I don't like about a lot of languages, they often involve a lot of ceremony. So, you know, one of Rich Hickey's big criticisms about something like Java and C# and even TypeScript or even JavaScript is that if you really continue to do like object-oriented programming, what happens is that you're going to write a class and you're going to declare your fields, you're going to write getters and setters, and you do a lot of bookkeeping. And in the end, what did you write? You wrote a class that represents people, and that thing is probably populated from a database table. So you just wrote 200 lines of code, and all it does is wrap a database object. And that's the type of thing that I think Clojure programmers hate, right? Why do I need to write a facade over a piece of data that I just got from the database? I would say in Clojure, the reason, I mean, that's just 200 lines of code you never write. I just write a thing that talks to Postgres, I get some data, and I'm done. I don't need to do anything else. I just write some functions. And to be very clear, like you can find people who write this style of code in JavaScript and Python and other languages that support basic functional programming, basic data style programming. But the problem is whether it's truly idiomatic in JavaScript and Python. My feeling is that the community around something like JavaScript and Python and TypeScript, they're still holding on to class-oriented approach, object-oriented approach to doing domain design, and that just leads to more verbose programs. And I would argue it's unclear as to whether those programs are less error-prone and free of bugs, because you're literally adding more layers. I think that's one of Clojure's true strengths, is that as a community, we believe that data-driven design is a first principle, and that by sticking to it, you can avoid a lot of these problems. Of course, you know, if you're listening to this, you probably have lots of questions about, that sounds great, but how do you do things like validation? How do you do things like specification? And fortunately, Clojure and ClojureScript are pretty old now. Clojure's 13 years old. ClojureScript's coming up on a decade. And we have a thing called spec. So for people who they like the data-driven design, but they want more confidence about correctness, there are tools that are continuing to improve that allow you to do a data-oriented approach without getting rid of all your confidence about correctness and maintenance. Because those are important, right? That I think is the critique of a data-oriented approach with languages like JavaScript, is that if you want to sort of scale it up and you need to maintain the software, how can you feel confident that you can make changes and it's not going to be sort of arduous and riddled with bugs?
I always, in discussion with some statically typed guys, I always ask them how the system could with the rest of the world, which is always changing, and there is no type notation, and they could no share the type notation with the rest of the world. And my first question: how do you parse some JSON, which potentially from some REST API coming from REST API, which can change eventually? And if you wrote all the Scala or Haskell or Java classes, and then you can get anything from the world, so how are you gonna deal with this? And we are, as a Clojure developers, always expect anything, but it's just a JSON, some generic data.
Yeah, the common, I think
Yeah,
the common misconception. Sorry.
No, go ahead.
Okay, thank you. I guess there is a common misconception and misunderstanding about abstractions. Abstraction as a thing. People tend to not think about the data as being abstraction by itself. And when people say, I need an abstraction for that, I need a representation of this, they always think about interfaces and code first when they come from object-oriented land. And that comes from the main thing, I think, of data-driven development is that instead of representing and simulating worlds with an object, we represent not the things in the world directly, but we represent our knowledge about these things, and that is a big difference. And from there, you can understand that the data itself is an abstraction. If you have a record which states, like a hash map, which states that here's the person name, here's the person address, and here's his friends and contacts and stuff like that, this piece of data already is abstraction, and you not necessarily need to wrap that into some code, like.
I agree. I definitely agree. Yeah, and again, I like personally, I think that, again, my opinion is that I think one of the problems of the way that people talk about these things is that there are trade-offs. Like, I think functional programming are great. If you want to use Haskell or if you want to use Scala or any of these things, I think it's totally fine. TypeScript's cool. I think that, I've been doing it long enough where, I never worked on a, for example, like a good example is like this, like, a lot of the stuff we have to do when we're doing Clojure, we have to deal with Java. And, a lot of times when the Java is painful, like we don't care about the types, right? When the Java is painful, it's because the thing that we're using was badly designed, right? And that has nothing to do with types. And this is something that I think that people don't talk about enough. Types are great because if you have a great design, they give you confidence about that the fact that you made the right choices, right? But there's so many software projects where the types are working out, but the software is unusable. It's unusable. Nobody wants to use that thing. It's too hard to use. And that means that the source of quality comes from somewhere else. Go ahead, Nikolai.
Yeah, so I think one of the problem of type and type system that it's extremely hard to design the right type system. So that's the real biggest problem, because the classification is a real problem. There can be multiple classifications, and I think it's still essence of the types, that it's definitely very, very hard to design the good type system. And that's why most of typed systems are. Okay, yeah.
No, so I agree with that, but there's another problem, which is that, like, here's the problem, right? So basically any feature you create in a programming language will be abused. It will be abused. Like, I find it, like, for a while I was dabbling in Haskell, and I found it very interesting because there's people in the Haskell world that are like, they're doing very fancy things with types. It's very sophisticated. I mean, it's amazing. I mean, if you're into that stuff, it's really mind-blowing. But then you read, Simon Peyton-Jones comments. Simon Peyton-Jones maintains the de facto standard Haskell compiler, the Glasgow Haskell compiler. And he doesn't use any of that stuff. As far as I can tell, his use of the types in Haskell it's like straightforward. It's very clear. And then I realized that, like, the problem with any powerful feature, and this goes for Clojure. Clojure also has powerful features that were abused, especially in the early days. Macros are a good example of this. We can talk about that later. And I think it's really challenging to get programmers to not use things that they don't need, right? If you give somebody types and it's really sophisticated, then they're going to over-specify, and then suddenly you're getting a different payload than you expected from a service that you can't control, and your over-specification is not doing you any favors. Or a Clojure program, and there's macros everywhere. And now, what's the point? Because you didn't want to use a DSL, you just wanted to write functions, you wanted to write data. I would say that that's really something that people need to understand when it comes to a programming language choice, is what is accepted, what's idiomatic, and what's relatively common. And as an outsider Haskell, I can't tell you, but the people that blog about it often try to do fancy type stuff. When I look at the Clojure community, I would say it's becoming more and more uncommon to see people writing about macros, because macros are cool, but they're not important. They're not critical to writing good software. I think that that's what I like about the Clojure community, is that in Clojure, even though there's a lot of powerful stuff, the community as a whole, and the libraries that you're going to use, have aligned around the fact that there's a simple part of Clojure that you should use, and most programs don't need anything more than that. And that's probably my criticism of, if I had a criticism of JavaScript, you know, I have to write JavaScript all the time still, is that, again, there's not much unity about what JavaScript is, right? JavaScript is kind of a multiverse, and with all this sort of like build tools, very fragmented now as to what JavaScript really is.
Do you see that JavaScript developers tend to pick these ideas of data-driven development up since did it change since the early days of ClojureScript, and how big the gap between what we do in Clojure and what does the global JS community typically do in their programs?
Great point. I would actually say, when I compare the typical Java program now, like there are two types of integrations I have to do all the time. So I'm a Clojure developer, but that means I'm a JavaScript developer. There's no way, right? There's no way to use Clojure without knowing Java. There's no way to do ClojureScript without knowing JavaScript. And I would say it's really funny that I see two, like Java weaknesses, which is that often the API is extremely convoluted and it requires a lot of boilerplate to do anything effective. JavaScript APIs are often actually quite simple. They're usually even if it's gnarly inside, the JavaScript library presents a simple interface. There's only a few functions. They exchange data-oriented stuff. So that's cool, but there's a different pain point, which is that when I use JavaScript library, when I use a Java library, it stinks because it's complicated, but usually there's only a few dependencies and it doesn't really complicate my build story or my deployment story. Whereas in JavaScript, yes, I get a nice library, but then I also got like 200 other dependencies that I don't care about and my build started failing. So you see that these two ecosystems have a very different set of values. Nikolai, go ahead.
Yeah, so just funny story. So maybe like a half years ago, I helped with some Amazon startup, and the guys set up the just empty project for the JavaScript, Node.js, React stuff, and it has 1 million of dependencies. 1 million of dependencies. Oh, yeah. I don't know any other software which can have 1 million. And it was empty project. Just Apollo, GraphQL, TypeScript.
So I just want to add to that. It's so funny because when I first started doing ClojureScript has a standard library that's 10,000 lines of code. And when I started, you know, it was always like, oh, we have to compare ourselves to jQuery. jQuery is like 35 kg zipped. And you know, we were really struggling to be smaller than jQuery. That was our benchmark. We have to be competitive with jQuery. And you know, you do any basic thing with JavaScript now, and there's no way there's not 10 megabytes or more of JavaScript in your directory for the simplicity. So what's amazing is that we continue to use actually jQuery as our baseline, and because you continue to say a trivial Clojure program should never be more than 25 kg zipped. And it's been amazing to see JavaScript continue to explode in terms of the size of the basic project. And we've stuck to our 2011 standard. We should never be more than 25 kg zipped. And you know, we can't control React, right? Of course, if you're going to start using React-based components, you're going to have to take on the burden of that dependency tree. But we believe in that ClojureScript is going to last beyond all these various fads. And so one day, we hope that something that gives us what React offers, but it provides a more sensible dependency graph.
Speaking of other value propositions of data-driven design, is that when we separate our code from our data and we manipulate the very same data types, like maps, vectors, and sets, and primitive stuff, when we do that, we actually free to perform hot reloading of that on JVM and both on JavaScript environment and stuff like that. So maybe it's time to see the how ClojureScript actually looks like. Like, what is it?
Oh yeah.
Isn't it a time for
So-
demo or something?
Yeah. So, but let's set it up for people who aren't familiar. So, JavaScript is dynamic, and even though people, there's no reason to use it in a normal programming. JavaScript, because it had eval, always supported this sort of like dynamic style programming, and that supporting eval, of course, is old. I mean, Lisp, one of the earliest versions of Lisp had eval, and actually, back when Lisp had it, it was a shock because at the time, you really, the most common way to do metaprogramming was to do like, assembly, and Lisp demonstrated you could have runtime metaprogramming without being low level, that you could be high level and have metaprogramming. And pretty much any language that supports eval really owes it to Lisp if it eval in a high level way. What's happened though, just to set it up, is that JavaScript always supported hot code reloading. It's just the nature of JavaScript. But it turns out, as Andre was alluding to, is that hot code reloading becomes harder in user land because that people write programs. If your program is stateful, if there's a lot of stateful resources, if there's lots of stateful data structures, then reloading your program doesn't really work, because how do you know you're going to end up in a good state? And it's quite a bit more effective in a language like Clojure and ClojureScript, because again, since the underlying application state is immutable, you're relatively, and state isn't hidden in some object or some class. We're not hiding state, right? State has been decoupled from business logic. You reload the program, it just works. You have new functionality, and you have state, and the state hasn't become corrupted. So that's the benefit. The other thing that I think is important is that it's worth talking about the REPL. So so people, like, you use the JavaScript console, but the JavaScript console is not really a live programming tool. The way that people use the console is you write a bunch of code, you run Babel, or you run TypeScript, and you refresh a web page, and then maybe you write a bunch of stuff in the developer console. But Clojure comes from a Lisp background, where Lisp, traditionally what you would do is say, I have a remote process that's running Lisp, and I want to, for my editor, to connect to the remote process and then investigate the state of the program, or write code in my source file and update the program on the fly. That's a very basic value that Lisp systems tend to embrace, and Clojure definitely does. So the thing that I'm going to demo is, I, as a ClojureScript developer, I can be in the browser, but from IntelliJ, you can use any text editor. It doesn't really matter, but I'm going to demo it in IntelliJ because that's what I use for work. I can connect to a browser and investigate the state of the browser, write new functions, and keep programming, and the browser is open. I never have to refresh. I'm just programming. I can do that with Node.js. So in my work at Vouch, we do a lot of work in Node.js for testing various other reasons. And again, I can run a node process. I can have my editor open. I can edit my source files. I can reload those files, and I never have to restart the state of my system. The last demo I'm going to show is I can do React Native, and I can actually have a REPL connected into React Native, and this is not just React Native refresh. I can change the UI, and it won't blow away the application state. Whereas React makes this possible. They have this thing, something called fast refresh, but you have to follow a bunch of rules. And in ClojureScript, there's no rules to follow, because again, the way you're doing the UI programming just kind of works. But maybe before we dig in the demo, is there something, I'm trying to explain this to an audience that may not have this sort of frame of reference. Are there other questions before I show that working?
Maybe let's go to the demo, and then we can get back and try to discuss some architecture. Well, yeah.
Okay, so I'm gonna So let me show. Can you see my screen? I hope so.
Yeah.
Okay, so here I'm in IntelliJ. So I like IntelliJ because actually IntelliJ has a really great plugin by this person, Colin Fleming. It has all the things you expect. You know, I can write functions here. You know, this is silly. I can save that, but I get auto completion. Notice that it knows what definitions there are, whether they're private, whether they're public. I mean, all the IDE stuff that you're used to from IntelliJ, it just works. I can jump around, right? So that's the reason I use IntelliJ, is that all these sorts of things that these IDE affordances are present. You don't have to use IntelliJ. You can use VS Code. You can use Vim, Emacs. I was an Emacs user for a long time. I mean, what I'm about to demonstrate, the REPL-driven stuff works anywhere, but it works great in IntelliJ. First off, I'm just going to show I can launch a node REPL here. So what I've done is that here I have my source file open. So this is not like what you're typically doing when you're doing Node.js development. Here I have this open, and then I can go, I want to load this file. And here I can go, I want to switch into this namespace. This is a namespace. It's an organization method for your code. And I can write foo12. Like I have a new definition. I decide I want to change that definition to a multiplication. I can redefine that, and I can like that. But I mean, I think that, you know, this is not a typical JavaScript workflow, right? I'm showing you that with the sort of Lisp approach to REPL, you're always live programming. You're always reloading, and you're never stopping. There's no I refresh something and then I try it out. I'm just running the node process. I write my code. This is, I mean, if you like testing, this is beautiful for testing. You can just be in a test file, change your one test, retry that test, try all your tests, and it's very, very, very interactive. Combine this with functional programming and the data-driven design. This is why people, it's hard to get people to try Clojure and ClojureScript, but the moment they try this, and they get to some testing and they get to some data-driven design and the REPL, they never want to go back, because I would say still to this day, it does not matter what language you're talking about, with the exception of other Lisps and maybe Erlang, you do not have this level of integration between the source code that you're writing and the interaction model that you hear. People have attempted it in JavaScript, but as JavaScript has embraced ES6 models, it's becoming harder and harder for that to work in a way that's like fun. And we've gone out of our way to make sure that this works with ClojureScript. So this is one of the REPLs, and I'm going to close that one, and I'm going to launch a different REPL. This is the browser REPL. It's going to automatically open up my preferred browser. It'll take a second. So here I see a browser. Again, I have a REPL, and I can, again, load that. It printed hello, and this is running in the browser. I can go, let's switch in this namespace again. I can make a definition, x5, right? And if I go here and I go into the console, is that it? What is it? Hello, sorry. Hello, core. Right, so this is really a truly like, the program is a living thing. I mean, this is a very old idea. It comes from Smalltalk and Lisp. And so this is really how we work. We want to have a live connection to the software that we're building. And it does not matter if it's in the browser. It doesn't matter if it's in Node.js. And now I'm going to show you this is true for React Native. So here I have iOS open. This is a React Native application. And simulator, this could be running on the device. It works on the device. It works for Android. And I've defined a new definition. So this is actually running inside. I've created this function called foo, just like before. That's running right on the iOS device. I can change this definition just like I did. And then I can go. That just works. And then this is live code. Like this is the state, some state. So I'm going to make a bit of state, So this is some state, right? This is inside of the running iOS application, this state. The value of that is current bar. Now I'm going to change this to be blue and see, that's not just a React refresh because nothing happened to the programming state. That's been unchanged, right? So we are able to hot reload our own stuff. You can edit the UI, and we're never going to change this pure functional state that represents the state of your application. So this is I'm demonstrating, even though these all seem trivial, these are exactly how I do my day-to-day work. And I use all of these tools. I'm programming ClojureScript in the browser. I'm programming ClojureScript in React Native. And I'm programming ClojureScript in Node. And we always have the REPL open. We use it to write programs. We use it to write tests. Hopefully that makes some sense. I'm going to go ahead and stop this and go back to talking. And maybe you all can give me some questions again.
Thank you.
Yeah, I guess now the audience is convinced to at least to try ClojureScript out, because the value proposition, the way you paint it is just tremendous. Like, I used to write Clojure. I used to write a lot of Clojure, but I tend to forget how great it is.
Yeah, that's funny that mostly people who are doing like JavaScript with React, to get this live reloading stuff, they need to do some rituals, I don't know, do something special. And with Clojure, we get this for free, just because Clojure program written in that way, which is compatible with the live reload and the REPL.
That's right.
So the thing you just show us, it was called Krell. Can you expand a little bit on that? From what I know, this is the last thing you've been working on lately. Is it some tooling for React Native and ClojureScript?
Yes. So the reason my company ended up doing this, supporting my development of this tool called Krell, is because React Native is now, it's been around for 5 years, and I would actually argue it's much better now than it was in the early days for a lot of reasons. I mean, there's more stability, but auto-linking really fixed one of the biggest problems about React Native, which was reproducing a build. Auto-linking really just removes a major pain point. But what happened was that the most popular tool in Clojure and ClojureScript was this thing called Renatal, which was written in CoffeeScript, and it controlled your integration with React Native. And it worked fine. We built an application with it, and it worked fine. But what happened was that we really wanted something a lot simpler that allowed us to upgrade React Native freely. And in fact, a tool that doesn't know anything about React Native. So this tool that I built called Krell, it doesn't know anything about React Native. All it does is that it creates a very specific root view for your React application that ensures that there's a socket REPL loaded and that hot code reloading works. Besides that, it does not know what React Native is. It just provides the socket connection and the hot reloading functionality. So it's a lot simpler. That means we can upgrade React Native whenever we want, and our tool, since the touch is very small, it's not a big deal. It's become, even in a very short amount of time, there's a good number of Krell users because people have been looking for a simple around React Native. There are others. Don't get me wrong. There are alternatives. There's a thing called Shadow, which actually provides a really great experience. There's another tool called Figwheel, which I think is enhancing their React Native experience. But the point here is actually that there's actually a bunch of great simple tools. All three of them in the ClojureScript world. All three of these tools are geared around providing hot code reloading it's zero configuration. When I say zero configuration, you know, when you look at what you have to do for hot code reloading for JavaScript, you should be scared. Sorry, yeah, just share the screen real quick. This is the total configuration for the demo that I showed that's specific to ClojureScript. This is it. This says that there's my main entry point is this file which you were looking at. I generate a thing, and there's the output directory. There's no other messing around. There's no language specific changes. There's really nothing at all about hot code reloading. There's nothing that you have to remember. There are no special cases. It just works. And I think that's really huge. When you look at the state of hot code reloading in JavaScript, generally there's a lot of caveats. And in ClojureScript, it does not matter what tool you use really these days, especially in the past, again, the past 5-6 months, they're all this forward.
The fun fact you didn't mention is that ClojureScript is actually bootstrapped from like 2 years ago or so, I guess. So what you did manage to do is that you are able to compile ClojureScript in ClojureScript itself. So you can write a program that compiles ClojureScript inside the browser or any other JavaScript runtime. And I guess it is even possible to compile ClojureScript by ClojureScript itself.
Yeah, that's pretty old. That's years ago now. I think it was 2015. So, you know, when Clojure first came out, you had to run Clojure. You have to. I mean, generally, people run Clojure to run ClojureScript. You run Clojure, Clojure runs ClojureScript, and you get the thing that you want. In fact, all the demos that I'm showing, it's ClojureScript being run by Clojure. But we do offer this thing called Bootstrapped, which again is not the main way because to include the compiler into the runtime, it's actually fairly large. Gzipped, it's 300K. I mean, 5 years ago, I was like, that's really big. So with your average React application, that's not very big. But
and that leads us.
But
sorry.
Go ahead, Andre. Go ahead.
Sorry. Just finish your thought.
Yeah. So all I was going to say is that we offer it. You can bootstrap ClojureScript. ClojureScript can compile itself. Then you can use it inside the browser. You can use it to make like, you know, sketch notebooks, and you can use it to make interactive guides. Like a lot of people are building tools for beginners. I mean, and if we want to make a REPL on like a long outstanding to do, we want to make a ClojureScript REPL for the ClojureScript website. So there's all these use cases which Bootstrap lets us do. It's still not the main thing, and it's unlikely to be the main thing because again, we believe that our sort of stance that ClojureScript should be practical. It should never be bigger than jQuery. That's something we've stuck by, but we offer it for people, this bootstrapping feature for people who want to do something different or that requires a different approach. Go ahead.
But anyway, you can compile the ClojureScript with ClojureScript, not with the Clojure, and that lead me to another tricky question. What do you think? Could ClojureScript in some future make a better Clojure? Like, given the fact that ClojureScript is written in ClojureScript, and that it eliminates some features of Clojure, like dynamic vars and namespaces, and these things together can possibly lead to more lean Clojure runtime, and the compiler you have can be universal, can be used for compiling to JVM bytecode, and that could possibly lead to other targets like native or WebAssembly and stuff like that. Did you thought about this development of Clojure? Like, is it possible that Clojure will become the better Clojure? I'd say.
It's Go ahead, Nikolai. Maybe you have another thing to add. Go ahead.
Yeah, that just some addition to this question, because now we have a Node.js runtime, and if we were thinking about the ClojureScript in a browser or on a mobile device, yes, we had this limitation. We want to reduce the size and sacrifice some dynamic nature, but now we have a Node.js runtime. And if we're targeting the ClojureScript with a Node.js runtime, the things can change. So maybe you know about the project like Macchiato and stuff like this, and you said you are using Node.js on the back end. So yeah, that's all.
So there's a couple efforts. There's a thing called Lumo, which is a bootstrap thing. It's not super active, but it does work. It lets you run ClojureScript programs directly in Node, and you don't need to use anything else. And people are using it for stuff, and it's very cool. So you don't need the JVM with Lumo. There's another really cool thing called Plock. Plock uses Apple's JavaScript core, which compiles on all major operating systems, Windows, Linux, and OS X. Plock is a self-contained thing where it uses JavaScript core. It has the entire ClojureScript runtime embedded in it. So if you want to do shell scripting with ClojureScript, Plock is another good option. But it's tricky because the thing is the world is continuing to move. And like one of the most interesting things in the JVM namespace is Graal, actually. You know, Graal actually opened up a ton of doors. You can do native binaries. You can do a lot of interesting things with Graal that weren't possible before on the JVM. So there are options now to create small executables, Clojure programs that start instantly. So I expect the JVM to continue innovating there. And you know, if small executable and fast startup time is your primary concern, there's already tools for that. Back to Andre's question, though, I think a really great one, which is that I think I've demoed that, you know, we can do browser, we can do Node, we can do React Native, and actually we're available on the JVM and the CLR, but of course there's other interesting targets. You have things like Dart. I mean, also you have, you know, Dino is just JavaScript, but there's also Dino. Maybe there's some things we would do there. WASM is, of course, a thing we wanted to act on many times, but it's just a matter of like time, you know, the time to work on that. I mean, the cool thing about Clojure and Clojure, they are pretty simple languages. And I suspect that if you're looking to do like target other things, there's without a doubt that ClojureScript is the easier place to get started. I don't think, you know, with Clojure, there's enough users, there's enough install base, and the development cycle is pretty, you know, pretty slow. And it's tight. And to be honest, it's tightly managed by Rich Hickey, which is totally his prerogative. If you're looking to target other things, then ClojureScript is a great starting point. You know, it's actually something that I want to see. I've been actually pretty curious about Dart, for example, because I think Flutter is pretty interesting. It's another interesting way to target a lot of different environments, whether that's desktop or browser or mobile, with like a lot less like ecosystem complexity than JavaScript. And I would love to see people tease apart the JavaScript parts from ClojureScript so that it's easier to reuse ClojureScript in that way to hit other targets. So my answer is yeah, a big yes. ClojureScript is actually a great way to get Clojure done in other places. Tangentially related. I mean, one thing that's really interesting, but we've seen very little action on, is multi-threading. You know, that's one of the big differences between ClojureScript and Clojure, is that we don't support multi-threading because the JavaScript runtime doesn't support threading. But if you think about it, actually, ClojureScript has such an amazing discipline around immutability that we would be able to provide if JavaScript provides multi-threading. And we don't care. Like if they just had locks and atomics, we'd be done. We could have a fully multi-threaded, reasonably safe runtime where multi-threaded programming would be just as straightforward as in Clojure, and you wouldn't have all the traditional JVM problems, and that would be just phenomenal. You know, we're ready to go there if JavaScript goes there. So there's if you're talking about how much untapped potential there is for ClojureScript, I think it's huge. And in a way that I think in the end, because JavaScript has continued to embrace like sort of like traditional programming semantics. Yeah, you can do it. You could do multi-threaded programming in it, but it's not something to be excited about.
I think that it would be funny to compile ClojureScript into JVM bytecode, because from my experience of working with Clojure compiler, which is the Clojure lang compiler.java, that is a file of 10,000 lines of code of Java, which just does the compilation, the famous one with huge blobs of commented out experiments, stuff like that. From what I know, the ClojureScript compiler is built with a Clojure library called Analyzer, which provides much more comprehensible and easier to hack passes of the compiler and stuff like that. I think it does make sense to compile ClojureScript into JVM and just start experimenting in that area, because that would possibly lead us to aggressive dead code elimination, which you do on the browser. We can do that in JVM. We can get an instantaneous startup time compared to the old Clojure implementation and stuff like that.
Yep. So maybe we are getting too technical for our auditory. So let's. We have not so much time. So maybe David, you have a good feeling of something interesting in the future. So can you share with us some trends you see in front-end development or mobile development, which you think is very interesting and we should put attention?
Yeah, I mean, I think the main thing, I think you know, in the JavaScript world, the pendulum tends to swing back and forth, and often skipping like that. Maybe there's a better answer, or we could do it differently, and we don't have to swing. We can just actually take the thing we have. We can make it better. I mean, so one of the things I liked. I mean, there are two things. Some of these things are not actually not even like, they have nothing to do with technology. It's completely just social behavior. But something that I think that needs to happen in JavaScript, because JavaScript is great. I mean, it's very, I mean, when I say it's great, I mean, the number of affordances that are available to JavaScript programs is fantastic. I mean, any problem you want to solve, there's a JavaScript library for it, and that is good. But I think there like a social thing, which is a purely social programming thing, is you know, hoping that people begin to revisit their dependencies. And when they build a thing, I think it wouldn't be strange for somebody to start a new set of libraries that says we take on no dependencies, and a new route where the dependency graph is very shallow, and then people can start building stuff based off very shallow dependency graphs. Like, that's a very easy thing to do because it has nothing to do with technology. It's just behavior. The other thing that ES6 lets us do, and it's like Rollup sort of started it. Rollup uses imports and exports. The fact you have static import and export, even though people keep wanting dynamic imports, which I'm like, it's not that important. It's not really not that important. With static import and export, then you're able to consume a very large library, right? That library can be large. Think about this. Shallow dependency graph because you don't want it, but then you also might get a bigger library. It's ES6. You use ES6 export import, and now Webpack or Rollup can dead code eliminate all the functionality in the large library they're using that you didn't actually import, right? That's a very simple, basic thing that I think needs to be done, right? The people complain about React, but it has nothing to do with React. I mean, it really has nothing to do with React. This is just a JavaScript problem. If you fixed it, again, with a little bit of technology and a bit of social programming behavior, you could get all the benefits that people want without these ridiculous payloads. I think that is actually a very important, interesting way to pursue, and I think in the end would solve most of the sort of like bloat that you're seeing in this space. And of course, this idea that I'm talking about it's not new. ClojureScript uses Google Clojure, well, which uses dead code elimination, and it's been great, and that's how we can generate. I think ClojureScript, the smallest ClojureScript application generates like 75, 80, maybe 90,000 lines of JavaScript. In the end, we get a 25K gzip thing, but that's because dead code elimination, it works. And it definitely works when we want to use large libraries and we need to eliminate something. That's only true for Clojure, but we use a lot of stuff from Google Clojure, whether that's internationalization or currency formatting. There's all this stuff, date formatting, all this stuff. You know, think about Moment.js. It's so big once you bring in internationalization. And the fact that Google Clojure gives us internationalization, but we get dead elimination, we only get the pieces of internationalization that we need. We don't have that problem that JavaScript programs tend to have. So I think that this is one of the biggest areas. JavaScript has clearly succeeded, but I think there are things that could be done to make it better for everybody. And of course, it would make it better for us because we integrate with via bundlers like Webpack. So if JavaScript solves that problem, it solves that problem for us too. So we definitely are interested in that. But I think I'll leave it there. I think hopefully that at least says some of the things that I would like to see happen, which again, is not even framework things. It's just write simpler programs, have simpler dependencies, and write better tools for dead code elimination. And write libraries that support dead code elimination.
So thank you, David. So maybe some light questions. I don't know. Do you have any books which professional life, like just a couple of them?
Books. I mean, the thing is, I'm a big programming languages nerd, so most of the books I like are not that practical, right? Like, you know, if you're like interested in learning more about Lisp, and you know, I would say, you know, the structure interpretation of computer programs is quite good. Sometimes people, structure interpretation of computer programs. I think if you have a little bit of a good math background and you're not afraid of math, then whatever you think about programming, that book will just tear all your ideas about programming down and rebuild it. So if there's one book and you're not afraid of a little bit of math, book to read, and you'll be like, okay, Lisp, I got to try it. Other books, Paradigms of Artificial Intelligence Programming. So, you know, when I'm looking for a great book about data-driven design and thinking about data-driven program, Paradigms of Artificial Intelligence Programming by Peter Norvig. That's one of the greatest books about how you can write data to drive the program. Also a Lisp book, but you don't have to like Lisp. Like you can read that book and not care. Still, I would say that it will change the way you write programs.
Okay, so yeah, I thought that you haven't finished yet, so I thought that we had a little bit more time, but unfortunately we had to wrap up. Thank you very much for your, David, thank you very much for your thoughtful answers.
Thank you, David.
Very much. So there is a link to Zoom below our experts. So somewhere there, please join us. I hope that, yeah, somewhere there, exactly. So thank you, Andrew and Nikolai, for your good questions. You did a great job. So see everybody in Zoom later. Thank you very much.
Right.
Bye.